This right here is a diagrammatic representation of Young's double slit experiment. So here I have a screen, and on this side I have the two slits, double slits, and if I pass, let's say, a red light through the two slits, I could use a laser for that, I would get an interference pattern on the screen in front of it. And this right here I have shown the interference pattern, which is nothing but a sequence of bright and dark spots. So these red things right here are the bright spots, whereas we have the dark spots in between them. Now we have the concept of fringe width, upon which the exercise is based. So let's talk about that. Fringe width is nothing but the distance between two consecutive bright spots or two consecutive dark spots. So let's take this as the first one and that as the second one. And so this distance right here is the fringe width, denoted by the symbol beta. Another very important variable in this is the distance between the two slits, which is this distance right here, right? The distance between the two slits, and that is denoted by a small d. Also, we have the distance between the screen and the slits. So let me denote that here by a capital D, and I have the three variables. Also, an important variable, last one, is the wavelength of the light being used, and obviously we denote the wavelength of light with the symbol lambda. So lambda is the wavelength of the light that I'm using here. And now to relate all the four variables here, we have the expression beta equals lambda times capital D upon small d. So the fringe width, denoted by beta, equals the wavelength of light times the distance between the screen and the slits divided by the distance between the two slits themselves. So this expression has been derived in the previous video. If you are unclear, I encourage you to watch that video there. So now let us go through the approach that you need to keep in mind while solving problems related to fringe width. So we have four variables here: fringe width, wavelength, distance between the screen and the slits, and the distance between the two slits themselves. So four variables, which means to solve such an equation, at least three of the variables must be given in the question. So all the questions that you do, any three of the four variables must be given, and you have to solve for the fourth variable. Now obviously some questions might be tricky, and so they might give you the distance between the first and the third fringe, let's say. So obviously you need to divide that by 3 to get the fringe width. So obviously you need to manipulate the data given in the question so that you can get 3 variables out of the 4 variables and solve for the fourth one asked in the question. Now let me take an example of one of the questions given in the exercise and work through that to make you understand the approach that you need to keep in mind while solving such questions. So the question goes something like this: monochromatic light of wavelength 450 nanometers. So I have the wavelength there, which is given as 450 nanometers. Shines onto two slits separated by 0.9 millimeter. So two slits separated by 0.9 millimeters, which means the distance between the two slits is 0.9 millimeters, and in an interference experiment. How far should the screen be placed, which means this distance. So I have to find this. They're asking how far should the screen be placed from the plane of the slits to get a fringe width of 0.2 millimeters. So fringe width is given as 0.2 millimeters. That's the fringe width right there. So I have the fringe width, I have the distance between the two slits, I have the wavelength of light. So I have 3 variables right there. I know the value of them, and I have to figure out the fourth variable, which is d. So first of all, obviously I'll plug them in, but keep in mind, before plugging the variables values into the equation, always it's a very good practice to convert them into SI units. It's always, it keeps things coherent. So it keeps everything consistent. So 0.9 millimeters is nothing but that simply equals 0.9 into 10 raised to power minus 3 meters right there, and this thing would be equal to 450 into 10 raised to power minus 9. It's nanometers, meters, right? It's 450 into 10 raised to power minus 9 meters. 0.2 millimeters would become 0.2 into 10 raised to power minus 3 meters. I've converted everything into meters, SI units, and now I can plug them into my equation. So fringe width is 0.2 into 10 raised to power minus 3 meters. I'll not write the units for now, they're the same meters, so you can skip them for now to keep things neat. Lambda is 450 into 10 raised to power minus 9, and D, which is something I need to figure out, so I'll just put that write that as D. So I'll just make some space. Yeah, perfect. Divided by the distance between the two slits, which is 0.9 into 10 raised to power minus 3, again meters. Now I have the equation and I have all the values plugged in. Now I can see I have only one variable D there, so I need to solve for D. So before proceeding further, I think I should switch the equation. I should just flip the two sides. I should write this on that side and that on that side, just to get the variable on this side. It just looks good. So there I go, flipped. I think that looks a bit confusing, so I should just change the color of these values around here to just make things easier to understand. So there you go. Now to solve further, I need to multiply both sides with 0.9 into 10 raised to power minus 3, because obviously I wish to solve for capital D here, right? So I multiply both sides with 0.9 into 10 raised to power minus 3, even on this side, into 10 raised to power minus 3, and obviously this whole term cancels out with this term, and I'm left with this. Now I have 450 into 10 raised to power minus 9 into D. I need to get rid of this, so I need to divide both sides with 450 into 10 raised to power minus 9. So I divided by 450 into 10 raised to power minus 9, and also on this side 450 into 10 raised to power minus 9, and this whole term cancels out with this term, and I'm left with only a D on this side. So D equals all this thing here. Now I have solved it for D, but I need to solve this thing here into a very proper and neat number. So what I usually like doing is segregate the simple decimal numbers and the exponents into two different groups and then solve them individually. That is generally easier to solve. So here I separate them. There I go. So D equals 0.2 into 0.9 upon 450, that's the simple number part, into 10 raised to power minus 3 into 10 raised to power minus 3 upon 10 raised to power minus 9. So there are all the exponents there. Now I can solve this part first and then that part separately. So 0.2 into 0.9 is 0.18, and 0.18 upon 450 is 0.0004. Simple calculations, division, and now 0.0004 into 10 raised to power minus 3 into 10 raised to power minus 3 upon whatever that is. So I need to solve the exponent part now. So 10 raised to power minus 3 into 10 raised to power minus 3 is 10 raised to power minus 6. So there I go. And now I need to solve this part now. So I need to take this 10 raised to power minus 9 to the numerator, and while doing so I need to change the sign of this minus 9. So this minus 9 will become a positive 9. So when I take this into the numerator, this will become 10 raised to power 9. So there I go. So I have 10 raised to power minus 6 into 10 raised to power 9. Now 10 raised to power minus 6 into 10 raised to power 9 is 10 raised to power 3, because 9 minus 6 is 3. So I am left with 10 raised to power 3. Now I have 0.0004 into 10 raised to power 3. I can just solve that and write D equals 1, 2, 3. I get 0.4, and it was meters because I had converted everything into SI units, which is meters. So I get D equals 0.4 meters, which means that to get a fringe width of 0.2 millimeters, or 0.2 into 10 to the power minus 3 meters, I should keep the screen 0.4 meters away from the two slits. And so yeah, by doing that I have found the answer, which is 0.4 meters. And you can follow a similar approach in all questions in the given exercise. In some questions you might be asked to find the fringe width or the wavelength of the light, or as in this question, the distance between the screen and the slits, or in some questions you have to find the distance between the two slits themselves. But you can follow a very similar approach. You have to solve for the, you have to first of all convert all the given values into SI units, plug them in, solve for the unknown variable, and then solve all that by separating them into normal numbers as you feel comfortable, and you get your answer right there, 0.4 meters, and you can then put the answer in the desired units. So the question asks the answer in meters, so you put them in meters, 0.4 meters, and you get. And yeah, that is the basic approach that you need to follow, and I hope you'll be able to do all the questions pretty easily. That's it for this video.